There we go.
Okay. So a number that is the square of an integer is called a perfect square. That's because we can look at this in terms of area. When you look at this square, what's the side length? What's the side length?
4.
4. So 4 times 4 is 16, right? Or in other words, another way to say that is 4 squared is equal to 16. Wait, 4 squared? Oh, that's where that comes from. It comes from the idea of area. Okay? Just so you know, cubed comes from the idea of volume. Like 4 cubed would be this square, 3-dimensionally. Right? 3 dimensions, therefore it's to the power of 3. This one's 2-dimensional, so it's to the power of 2. 4 squared is 16, and it comes from this idea here. Now there are 2 ways to read this, right? 4 to the second power equals 16, or 4 squared equals 16. Those are 2 different ways we can run those out, okay? Now, these are perfect squares we need to memorize. I'm going to add 2 more to your list, but let's just go through them, okay? You ready? What's 1 squared? Actually, I'm just going to start calling on people, okay? And there'll be a pattern. You guys have that pattern, or you've seen this pattern. We saw it on Friday. If you don't have it, just be like, just figure it out, okay? Use some side work. All right, Sarah, 1 squared.
1.
A little louder.
1.
1. Darius.
4.
Good. 2 squared is 4. Maddie.
9.
Good. 3 squared is 9. Can you phrase it in that way? Jason.
16.
4 squared is 16. Can you phrase it that way? Jeremiah.
5.
Can you say it 5 squared is 25? Phrase it that way. Chris. 6 squared is 36. Can you phrase it that way? Saeed.
7 squared is 49.
Thank you. Andy in just a moment.
High 5.
Mikkel.
That number times itself.
8. 8
Is 64. Aiden.
80.
Try again.
Wait, does number 7 say 49?
Yep, we'll come back. Luke.
10 squared is
Landon. 110 is 10 times 11 because you tack a 0 on 11. So we want 11 times 11. So what's 11 more than 110? There you go, 121. 12, Allie.
12 squared equals 144.
144. 15, Ashley.
225.
225. Lolly. 20.
1 times 20 equals 400.
Nice. And the way you can get that one fast is just do 2 times 2 and then tack 2 zeros on. And Stephen, 25. This one's a big one. We know it's bigger than 400. He's working on it on the side. Aiden, did you get yours?
81.
81, good. That's okay. We're gonna let Stephen finish working it out on the side.
Okay, Steven.
This is very good.
I got 605.
What?
I got 605.
It is not 605. Go.
525.
All right, I haven't called on Piper.
625.
625. Good. That's one you're gonna want to memorize.
Oh my God.
Okay. That one's a tough one. It's a tough one. There are 2 more we're going to add on here, right? So we skipped 12 to 15, but let's get 13 and 14 in there. And there are 2 kind of interesting ways to think about those. All right, so 13 squared is 169. So here's how we think about it. Right? Look, 3 6, 9. You see that pattern there? 3, 6, 9. 1, 3, 1, 6, 9. Now, 14, if you memorize 13, 14 is really easy. Because you take this, you flip it. 169 followed up by 196. So just for memorization purposes, right? Because I say memorize the perfect squares below. I think that you should have these ones memorized. This one might trick you up every now and then, but definitely 1 through 10 you want to have memorized. 12 is very common. I bet most of you have that one memorized by now. These two, probably not. You might need to do some practice on that one. But the way I remember it, 1, 3, 1, 6, 9, right? 3, 6, 9. And then I don't ever remember 14. I don't. I barely remember 14. But I have 13 memorized, and 13 goes to 14, and 14 flips that one. 1, 6, 9, 1, 9, 6. So I remember 14 that way. And then 15, 225. Followed up with 20 squared is 400. 25 squared is 625. You don't want to memorize that one especially. Brent.
So for this, like, can we work it on our notebook
For the memory test on Wednesday? No, it'll be a memory check. It'll be like 3 minutes. You'll have very little time. It'll be like look, click, look, click, look, click. It'll be like that too. It'll be like a sweet little dance. It'll be like look, click. It'll probably actually be like look, click, swipe, click, swipe, click, swipe. Done. That's probably what it will be. Probably what it will be. Alright, so these are things, these are called perfect squares, right? Memorize these perfect squares below. All these numbers are perfect squares. Now we're not talking about perfect squares today, we're talking about the opposite of perfect squares. So the opposite of squaring a number is called finding the square root. Everybody say square root.
Square root.
It's also called the inverse. So if squaring a number takes a number and makes it bigger, you're multiplying it times itself, finding the square root is getting it smaller and figuring out what number times itself is that. And that's how we get to this. So this is the square root symbol. Have you guys seen this symbol before?
Yeah.
Yeah. Well, hopefully you've seen it.
Calculators.
You've seen it now. Yeah, you've seen it on a calculator, absolutely. This is the square root. And this symbol actually means the square root of, right? It means the square root of. So in your example that you have, okay? In the example you have, if you have this, how would you say this? This Said?
The square root of 36.
The square root of 36, exactly. So the way we want to think about this, now I think many of you guys actually might just know this one. What is it? It's 6. And how do we know that? Well, there's a thinking process behind it. We want to think about this. You should think about this. What number times itself is 36? That is what the square root is asking. Okay? This is an important question. You should think, what number times itself is 36? That's important. Whenever you see a square root symbol, you want to ask yourself the question, what number times itself is this number? So when you look at this, you're saying the square root of 36. But what you should really be thinking to yourself is, what number times itself equals 36? And so we already know that 6 times 6 is 36. So that's the answer to my question. What number times itself is 36? 6. So the answer to the question, what is the square root of 36? The answer to that would be 6. Questions on that? This is the phrasing that you're going to want to remember. Okay? So let's practice. Okay? Talk to your neighbor about 1, 7, 12, 9. Square root of 49. I want you to ask them what number times itself equals.
7, 12, 9.
Let's do the first 3. Right. Jory, what do we got for the first one?
7.
Good. What do we got for the second one? Jack?
12.
12. What do we got for the next one? Madison? 9. Good. So those first 3 are pretty easy. Why is the last one a little tricky? It's a big number and it's not on our list, is it? So let's think about it for a second. We know that the number must end in a 5. The only way to get a 5 is to multiply a number times 5. Well, a number times itself. Okay, that's the answer to this question. What number times itself equals 2025? So we know that the numbers that we're going to have as options have to end in a what? In a 5. So what are the options we have? We know it can't be little, right? We already have 15 memorized. 15 is 225. So we have 25. What else do we have as an option? 55, 45, and 35. We got 4 options, really. It could be bigger than 55, but here's how I know it's not. Let's think about it for a second. This one's on our list. What is that one? 625. Okay? So I know it's not that one. How do I know it's not 55? Well, let's think for just a second. 50. What's 50 times 50? Let's back up just one more step. What's 5 times 5? So add a 0, and now it becomes 50 times 50. How many zeros do I need to tack on? 2. So 5 times 5 is 25, so 50 times 50 is 2,500. So we know it's not 55 because that's bigger than 50. And 50 squared is 2,500. So really we only have 2 options. And we just pick one and try it. So I'm picking 45. Picking 45. So I do 45 times 45. I do my multiplication, I do all the work. And it turns out, yup, it ends up being that number. So the answer to the question is, what is the square root of 2025? Or in other words, what number times itself is 2025? The answer would be 45. So did you follow the thinking through this? We had to use some number sense to figure out some options. We used some more number sense to eliminate some options. And we just tried for you. Okay. Okay. That's that. Let's do a couple of questions here. We don't want to mix up the phrases square of and square root of. Those are 2 different things. When I take the square of something, I'm multiplying a number times itself. It gets bigger. I take the square root of something, I'm asking myself what times itself equals this. And it's going to be small. So the square of 9. Square of 9. Luke is 81. Notice how it got bigger. The square of. Okay? The square root of 9. Jory.
3.
Is 3, right? It gets smaller. The square root is saying what times itself equals 9. 49 is the what of 7? 49 is the square root of 7. Brenna.
Square root.
It is not square root. Square root gets smaller. Square root says what number times itself equals this. It's saying 49 is the, Sandra? The square of 7. Notice the order, the pattern. 10 is the what of 100? 10 is the, Ashley? Square root of 100. The square root of 16 is, Desi? Is 4. Notice the pattern, the order that we say things. The square of something gets bigger, the square root of something gets smaller. Okay? All right, last little bit. Okay? Only square roots of perfect squares work out nicely. Notice of what? Of
Perfect square.
perfect squares. That pen just died on me again. Yeah. Yep, it did. Awesome. All right. Only the square roots of perfect squares work out nicely. The rest must be estimated, and we can estimate them. Okay, so if I want to know the square root of 50, why is that one a little more tricky? Ashley? Exactly. Did you guys hear that, what she said?
Yeah.
She said, there isn't a number times itself that will give me 50. It's not on our list, right? We have a list right there. Is it on our list? No, and we're going to have to do these without a calculator. So there's 2 steps, 2 questions to ask. What 2 perfect squares is that number between? And then which one is it closer to? Right? So first off, what 2 perfect squares is 50 in between? Look at your table that we wrote earlier. Find the 2 numbers that 50 falls between. Anna, what perfect squares is it between?
7 and 8.
Say it again.
7 and 8.
Those aren't perfect squares.
49 and 64.
Good. 49 and 64, which when we square root them, would be 7 and 8. Okay? So it's in between square root of 49 and the square root of 64. The The square root of 50 is in between the square root of 49 and the square root of 64. You with me on that? It's just in between. And now, which is it closer to? It's definitely closer to the square root of 49. The square root of 50 is way closer to the square root of 49. And so, we approximate. We say, okay, it's just a little bit more than this. What's a little bit more than 7? 7.1. Just a little bit more. If it was closer to the middle, we would probably say, oh, like 7.5, right? If it was closer to 64, it'd probably be like, 7.8 or 7.9. It's an estimate, okay? So, which is it closer to? It's closer to the square root of 49. So it's, our answer would be approximately 7.1. Cool, questions on that? All right, sorry about that at the bottom. For some reason it showed up early. All right, sometimes we want the square root of a number that's not a perfect square. We can estimate it though. Find the square root to the nearest 10th. We want to find the square root of 12. Is it between, okay, so we asked ourselves, square root of 12 is between what two consecutive perfect squares? What is the square root of 12 in between? What perfect squares is 12 in between? Say loud.
3 and 4.
We're looking for perfect squares. What?
6 and 16.
9 and 16. So 3 squared is not 6, 3 squared is not. But yes, you're right. So it's in between the square root of 9 and the square root of 16. So we ask ourselves then, what's the square root of 9? What's the square root of 9? 3. Okay. And the square root of 16 is? 4. So which one is the square root of 12 closer to? Well, this one's a little bit trickier, right? It's kind of in the middle, isn't it? But which one is it actually closer to? The square root of 12, square root of 9, square root of 16. It's closer to which one, Anna? It's closer to 9. Why?
Because you add 3 to get to 12.
Yep.
16 minus 3 is only 13.
It's like 13. It's only 3 away from 9. How far away is it from 16? 4. So is it closer to 3 or closer to 4? It's closer to 3. But it's not way closer to 3, right? We know it's a little closer to 3. So what do we think maybe the square root of 12 would be? It's closer to 3, but it's really close to the middle. We're just estimating, right? So there are a couple answers that would be correct. There's a couple that would be wrong. Tori?
3.4.
Sure. What would be a wrong answer?
3.9.
3.9 would absolutely be a wrong answer. Why?
It's 2.
Because 3.9 is would be like closer down the number line, but it's not that far down. It's closer to
Yeah, it's closer to here. 3.9 is all the way up there. Okay. What other number would be a wrong answer that's close to the middle?
I thought like 3.6.
3.6? 3.5 would also be wrong. Why?
Because it's not exactly in the middle.
Exactly. It's not exactly in the middle. Rarely are we going to put one that's in the middle. Rarely. It's not exactly in the middle. It's closer to 3, so we need to estimate closer to 3. So I'd say 3.4 is a good estimate. If you said 3.3, I would also accept that. If you said 3.5, I would not. Because it's not in the middle, is it? It's closer to 9. Right? 12 is closer to 9, so our square root of 12 would be closer to 3. Let's do the next one. Okay? Remember, this symbol means approximately or close to. So if you see that one, we know we're estimating. Okay? All right, here we go. Square root of 80. I'm already giving you the answer here. It's between 64 and 81, right? So since it's between 64 and 81, we can fill in our blanks and know which one it's closer to. So I think we already know where we're headed with this one, right? But let's still go through the process. Square root of 64 is, Mikkel? Look at our table. Look at the table. Square root of 64 is 8. Good. Square root of 81 is what? 9. And which one is the square root of 80 closer to? Is it closer to 8 or closer to 9? Landon. It's closer to 9, yes. It's obviously closer to 9. I say obviously because it has an 80 in front of it, just like this has 81. Of course, how close to 9? How about close to 9? It's like really close to 9. It's really close to 9, right? Okay? So what would our estimate be? The square root of 80 would be really close to 9. What would you say? 8.9? Yeah. And if you want to check your answers with a calculator, you just click the button, click the square root button. You can do that. But I expect you to estimate without a calculator. Okay? I expect you to do that. Okay? Cool. So you got square roots homework. This is assignment number what, 27? I think it's 27. Yeah, I think it's 27. This appears a little bit longer. The back is a little challenging. Only because I'm not going to specifically teach it to you. Right? I want to see if you can figure it out. Yeah.
Basically how to answer these questions. So I actually turned like my on. I mean like the A18 and A something. I actually turned that video like from on trying to canvas or something like that. And this is
This is not the time to take care of that right now.
I don't even know. We can. I think it's so short.
Now,
We can't even stand.
When you're thinking order of operations,
Is this so small?
ladies and gentlemen, thank you. When you're thinking order of operations, where should square root fall? What's square root really close to? What's it kind of tied next to?
oh exponent.
What's it tied with?
I thought exponents.
Yeah, why? Hey guys, I can't hear her. I can't hear her. Let's take care of our homework or organization in a minute. Let's listen to this because this is about content.
Because it's multiplying and dividing by itself. So,
Yeah, by itself. What's the square root, the inverse of? Square root, and then square of, okay? So if I take the square of 5, what's 5 squared? 25, that's exponents. So when we're doing order of operations, what should happen first? This. One dilemma, however, is that if I have square root of 10 plus 6, what do I need to do first?
You gotta do the square root of 10, and then you do the square root of 6, and then you add the square root.
Great idea, it's unfortunately wrong. Because if I were to write this in a different way, we write it like this, square root of 10 plus 6. Anything inside the square root is inside a grouping symbol. So if it looks like that, we actually gotta think about it like this. Alright? So I love the idea, it's just not right. But I'm cool with being wrong because it gives us a learning opportunity. So when we have our square root, there's an implied set of parentheses. You guys know what I mean by implied?
You put them in there.
It's there without me having to tell you.
Invisible.
Yeah, sure. So if I see the square root of 10 plus 6, what is that, the square root of? Square root of 16. Okay, which equals 4. All right? So that's just something to think about for the back of your homework. The rest of the time is yours. You have about 10 minutes to get started. I imagine you can take a look. I imagine you can get a good chunk of it done. Especially when you look at 14 through 17, we are estimating to the nearest 10th. I've given you some steps to help you with that estimation, so feel free to use that to help you out. Okay.
Big numbers.